So we're going to look a little more at these horizontal stretches and compressions. And we're just going to see why we haven't focused on them so much with our polynomial functions, and we started but didn't do very much either with our exponential and logarithmic functions. So if I graph these two graphs on my calculator, the first one, x squared, right, would just look like this, and I'm just trying to show the difference between the two. So if x squared looks like that, one half x squared, identifying this transformation, because the number is less than 1, we have a stretch, so a horizontal stretch of 2, because we have to flip that fraction. So this graph should be getting twice as wide. And that's probably an exaggeration, but the idea is we're stretching it out to the sides, okay? Now, did this graph get twice as wide, or did I vertically compress it? Because you could think maybe we just kind of push down on the graph, and it's hard to tell which direction it is. So it says it's difficult to tell if the transform function is a horizontal stretch or a vertical compression. This is because I can actually simplify this function. If I distribute my squared over multiplication, I get 1/4 and then x squared. So this could actually be rewritten to show a vertical compression, and we can see the graph, it's kind of hard to tell which one it is. With exponential and logarithmic functions, we have a similar thing where, because we can have lots of different parent functions, if I do this graph, now we have a number bigger than 1, so that would be a horizontal compression of 1/3. Okay, so we would be compressing the graph. Here's 2 to the x, let's say. And here's 2 to the 3x, compressing it in. You can see that also looks like a vertical stretch. And in addition, right, I can actually rewrite it as a completely different parent function. So I could write that as 2 to the 3rd, which would be 8 to the x. So because we have these different ways of looking at things, and it doesn't seem super important to have a horizontal stretch on its own, we haven't talked about them much. Now, the reason the graphs look like this, and it's hard to tell the difference, has to do with the fact that they go to infinity. So if I stretch something out and it's already going to infinity, maybe it heads there a little faster, but it doesn't really change the high point of the graph. If I have a graph that's on 0, right, that's my lowest point, and I stretch it away from the x-axis, right, that's not really moving it vertically. So it's just really hard to tell which is which. Now, the graphs we do this unit, there's going to be a huge difference when we do horizontal stretches and compressions, and they're super important for word problems. So that's why we're starting to look at them more. So we're going to work on a point next, transforming a point, just to practice all our different transformations together. For our second part of the lesson after we kind of reviewed everything. So determine the location of the following point 5, -2 after each of the following transformations. So we're going to identify the transformation, like this one is a reflection in the x-axis, because my negative's in front of the function. So if I reflect in the x-axis, right, go over the x-axis, that means the y becomes negative, so this is going to be the 0.5 +2. This is the reflection in the y-axis. If I go over the y-axis, my x is going to become negative, so this is -5, -2. And we're always going back to the original point. This one is up 3, and I suggest you trying these on your own. So up 3, right, my -2 is going to become a +1. This is left 2. So even though I see +2, if I go left, I need to subtract 2 from the x, so I'm going to get 3, -2. I have right 5, so I need to go and add 5. So I have 10, -2 to my x, and then we have down 1. So down 1 is going to be 5, -3. Now we're going to get into some stretches and compressions, and then the last row is going to be combinations. So this is a vertical stretch of 3, which means my x stays put at 5, and I multiply my y value by 3. This is a vertical compression of 1/2. Remember, vertical works just as I see it. So I'm going to multiply my y value by 1/2, and I'm going to get a -1. So push towards the x-axis. So here's my first horizontal stretch or compression. They work backwards, so if I see a number bigger than 1, I'm actually horizontally compressing it by the reciprocal of 3, which is 1/3. So that means I'm multiplying my y value by 1/3, or my x value by 1/3, because horizontal is x. So that's going to give me a fraction here. 5 times 1/3 is 5/3, and then -2. My next one, because I have a fraction, that is a horizontal stretch. And the reciprocal of 1/2 is 2, so that's a horizontal stretch of 2. So I'm going to multiply my x value by 2. Now this happens to be the same as right 5, only because plus 5 and times 2 are the same. So that will happen sometimes. I'm going to rewrite this as a fraction. So this is 1/5 x, so I can really see what's going on. So that's another horizontal stretch, this time of the reciprocal of 1/5, which is 5. Multiplying 5 by 5, I get 25, -2. This is a 5/2. So I have a fraction here, okay? But that fraction is bigger than 1. So when I flip this over, it's going to become 2/5, so it is a compression, okay? So this is a horizontal compression of 2/5. So I'm going to multiply my y value, or my x value, I keep saying that, by 2/5, and that's going to give me 2, -2. So 5 times 2/5 is 2. So now we have a couple transformations together. Often, like 90% of the time, it doesn't really matter what order I do them in, but I'm going to follow order of operations to make those decisions. So I'm going to do what's in parentheses first. So I'm going to go right 3, okay, and then I'm going to take that and I'm going to reflect it in the x-axis. I'm sorry, left 3 and then reflect in the x-axis. So if I go left 3, I'm going to write my starting point. Left 3 would be 2, -2. And then reflecting in the x-axis makes the y negative. So I'm going to get 2, +2. My next one, so this we'll just label these. This one is left 3, and this was a reflection in the x-axis. My next one, in parentheses, I have a horizontal compression of 1/2. So that's going to lead me to 5/2, -2. And then we're going up 5. So that's going to give me 5/2 plus -2 plus 5 is 3. Next one, I'm going to start in parentheses. This one definitely doesn't matter. This one, I'm going to first do a reflection in the y-axis. And so that's going to give me, making my x negative, so -5, -2. I can do both of these at the same time, but technically they're a reflection in the x-axis and a vertical stretch of 3. In essence, I'm negating my y value, and then I'm multiplying it by 3. So negate becomes 2, multiply by 3 becomes 6.